Hey everyone.
Day, mate.
Hi.
What was that?
That was good day, mate.
Oh, good day, mate. Because all I heard was, "God damn it." Good day, mate. Okay, got it.
So the right way would be a good day, mate.
Ah. Um, I see. Is it just? Ha, I'm gonna pronounce your name wrong. Is it Deshuan?
Yeah,
Hi,
hi, Dan. Yeah, this is De Xuan.
Deshuan. Okay.
Yeah,
Nice, nice to have you on the
yeah,
call.
yeah. Thanks. I guess mostly just listening to learn about
Okay,
the latest status.
okay. But this first, so yeah, let me share what I have for agenda. The first topic actually might be something you're interested in and can weigh in from the maybe from the hypervisor side. Let me share this. Where's the share button? There it is. Okay. Um, so this is the first topic maybe want to talk to you about. But before I do that, any other opens people wanted to talk about today that weren't on this list?
If you have a minute after all of that, I was wondering how much do you know about CXL ID?
Just enough to be dangerous, but
Okay.
okay. But we can talk about that because that actually something else that Anish had brought up as well.
So the following items are the topics we want to talk about today. Is it?
Yeah.
Okay.
Yep. Yeah, I was going to bring up because I think you'd asked this question about determining.
Yes, this one.
Yeah, I wanted to see if we got to an answer on that, or still is there still opens on that one. Um, okay, yeah. So yeah, we can talk about CXLID at the end here too. Uh, but this first one is um, I'm increasingly thinking that we need to do this. It it uh, it came to a head recently where I think there's a potential bug in one of the drivers that is passing one of these blobs around. Um, look for a patch shortly, but it just strikes me that um, every single vendor has a GHCI to pass data in shared memory. We're all going to implement it 3 or 4 times, 5 times over. These launch attestation interfaces also are passing blobs around, and they've done it. They've done the same data passing in 3 or 4 different vendor-specific ways, and it's just shared data. It's just blobs in shared memory. I don't think Linux needs 10 of these drivers. Um,
So this is a VSOC suggestion.
well, so I think I am not convinced that VSOC is kind of purpose built for this, if only because VSOC was built to go from host user space to guest user space, and not really. And what we want here, especially for some of these like um, cases where the TSM driver needs to kind of be involved and see the evidence going by and be able to do things like, oh hey, there's new evidence. Let me go ask the host over a secure channel to give me the digest of it, so I know it, so I can validate that this is the good evidence and help user space help guest user space process the evidence. So I think there's some value in having a host user space to guest kernel kind of transfer where the host on the host side we can say um, post evidence to guest, and uh, and the guest can retrieve it over some channel. Now, the easiest channel for Linux to handle would just be VirtIO. VirtIO, even like even a simple serial device, just a ring buffer. We just grab data over this ring buffer and off we go. But considering that, I mean, but that was the nice thing about VSOC is that Hyper-V has a VSOC, and it's basically you can't tell the difference between whether you're talking to QEMU VSOC or Hyper-V VSOC doesn't matter. If we do, but if we want to land it in the kernel, we need something different, and so that would probably it might be the case that we would have a layered approach where the interface to the rest of the kernel is common. So the guest kernel can say, give me the evidence for this device, and the back end would either be VirtIO or something with VM bus. But I've never played with VM bus, and this is where I wanted to get Deshuan's opinion about what could work here, and can we make it common and that kind of thing.
Yeah, the VSOC on Hyper-V is based on VM bus. A VSOC connection for Linux VM running Hyper-V is based on the ring buffer channel of a VM bus device.
So there's a VM bus abstraction for AF VSOC, but as far as the guest is concerned, it can't tell the difference between those two. But I'm not aware of VSOC being able to have a kernel based target. Right, because what we're looking for is the PCI core layer in the guest being able to ask this driver, give me the certificates, give me the measurements of this virtual device, and have that be transported over to have that request go to the VMM, go to the host. So, because otherwise, what we'd have to do is have guest user space do the VSOC and then inject the results into the kernel, which is kind of messy. But yeah, I think the next steps here is just to propose an RFC and see what people say. But I'm just announcing it here just to say, like, hey, I think I'm going to do this, and if you have a reason why I should stop and why we should go with the rewriting this same kind of transport 10 times over, please tell me. But I'm not really hearing that kind of objection.
Well, so I'm trying to think. If you do this VSOC, then when you do LSPCI in a guest, you'll get this new device. And you already have, well, I have a CV-guest device. So it's going to be like two devices kind of related to TSM. And then you need to pull all this VirtIO stack into the guest, which is fine for Linux. Linux does it all the time, but say Windows may not have it. Windows will include VSOC all the time, and Windows distro. And then it's quite a lot of code, let's say, that VirtIO guy. And
okay.
And this is to handle what, like GHCB exit from guest to KVM to get evidence. Then KVM would exit to QEMU. And KVM to QEMU interface is basically KVM run structure. which is shared to user space, we can make it platform agnostic and put the evidence page and all that stuff in that thing. So that would be platform agnostic. Platform dependent would be GHCB interface, which doesn't sound to me like too much work, too much code, because first we already have it.
That's also true because we don't the GHCB, we still need it because we need it for secure things too, and
Right.
this blob thing is only for the shared page protocol and not the private protocol, which we can't get rid of it because that's critical.
So you still go ahead, do the RFC.
Yeah.
I'm all for it. Maybe people love it. And
I've never seen people at Linux love anything. it's always a question of what they hate less. But yeah, I think, I mean, so but it would not, to your question, it would not be an additional device that the TSM layer sees. It would basically be something. So like the rough proposal was, you basically just call fetch blob. And you give it some kind of identifier, some kind of cookie or ID for the and then maybe some input parameters like nonces or other things that need to go along with it, but then some parameter block and
so that fetch blob is what, like libc or something in the guest kernel?
This is guest kernel.
Guest TSM module.
Yeah. Guest TSM core, something like this. So it would have an interface like this, and then the backend behind that interface, it would either call some virt.io channel or VMBus channel, or
well, for virt.io channel we'll have to have device, virt.io device, right?
For the virt.io channel, we had to have a device, but I'm not sure that it could just not be something that is internal to the TSM core. I'm not sure we need another driver or anything. I think it's just the well, maybe, I mean, that's a detail that'll come out in the RFC. But yeah, maybe.
If it's virt.io SOC, we don't need a driver, but we need a device which QEMU creates, passes to the guest, and then guest will see this virt.io SOC or something.
Yes,
they're all like devices, right?
Yeah. QEMU needs to create the device. You're right on that and Hyper-V would do the same thing for this itch thing. Something like this, but I mean, yes, it's not hard. You would think it's not hard, but yeah, we have found our first TSM blob transport bug, and so yeah, the chances of us being perfect are good, but not 100%. Anyway, I'll RFC it, and then if everybody hates it, I'll say that everybody on this meeting said it was a good idea. No, but that's a joke. We'll see. But just a heads up that what might come out of this is hypervisor requirements.
I think that the idea is to separate a specific fetch Coco blob operation from the guest request. But I'm not sure why host need to care about the difference between the real guest request and the Cocoa, the fetch the Cocoa blobs things. Because
you mean that we still have the same exit handler?
Yeah. For other, maybe for other thing, for other vendor specific guest requests, are there any?
I mean, right. We have lots. I mean, well, this is also another question. I mean, so the guest requests we have are, well, we have bind and unbind, but those are named operations.
Yeah.
And those need to talk to SPDM, and whatever message, and our TDIS messages, like we just send messages that say, like also unlock and run.
Then run becomes a specific, becomes a explicit request to the host. Is
yeah,
it?
Go ahead. Wait, yeah, go ahead.
In this case, guest will call the host using this VSOC mechanism, platform agnostic. This will land and say in QEMU. Then QEMU, again, platform agnostically, will call this netlink evidence interface, fetch the evidence from that pipe, then throw to another pipe to the guest in platform agnostic way.
Exactly.
Then we're done. We don't need any guest request. And if we're lucky enough, we can just make it between KVM and TSM and the host and skip exiting to QEMU, because it's like file descriptor and file descriptor, ideally, right?
Ideally, the KVM could generically say, oh, this is a PCI core evidence request. I know, as long as KVM knows the translation. Well, I mean, it could go directly. It could go directly to the PCI core and ask for it, or
KVM will see VSOC transaction kind of thing. So it's not gonna. It will be exit to KVM, and then KVM exits immediately to QEMU, and then QEMU emulates this VSOC, and then we're good.
We're good, and then it goes back. But I think the question for is that AMD. So like on ARM and Intel, we can, our other kind of secure channel requests do not need to exit to KVM. We can call our kind of like a hypervisor layer. We can call them directly with like TDG calls, and ARM has what I think it calls RSI calls or something like this. But AMD needs. Don't you still need guest requests to do things like?
Yes, we can eliminate your guest request, but we cannot eliminate my type of guest request. So I still need guest request IOCTL in IOMMUFD.
That makes sense. Yeah. So it would be a separation of things that if any other protocols that are going over shared memory would use this common platform agnostic transport thing. Anything that is a private kind of guest to TSM message, which I think only AMD has, that would use guest request. And I think for the CPU kind of hypervisor-ish TSMs, those would probably just have bind, unbind, and run, and wouldn't need guest requests anymore for those.
Well, start and stop are guest requests, right?
Start and stop are guest requests, but those turn into bind and unbind on the host.
They do.
They do. I think so, right? Or at least
bind and bind is the thing which disables DMA, say, right? And so the one pair is to tell the CPU you can enable DMA, and the other pair, which is start stop, is to tell the device it can do DMA.
Right.
So we need 4 requests to IOMMUFD. Beside other other calls like my encrypted enable SDTE thing, which is paired with bind or enable DMA in the host. But still, IOMMUFD needs to know about it.
I think it does, and I think this might also help with the discussion on the IOMMUFD side, because I think it makes a lot of sense for IOMMUFD to have a have explicit commands for those cases versus wrapping those in guest requests, and yeah, we can keep guest requests to things that are absolutely private that the kernel has no idea about and can't answer. They're just a private channel.
By the way, if you go that far, maybe we add start stop in TSM ops. Start stop the interface, because right now it's like packed into guest request.
Okay, I'll put that on the list of things to consider.
Split out.
If we do the separation where blob transfers are no longer on top of guest requests, and that means that we have a smaller set of things going through guest requests, should we actually move a few more operations that are in guest requests, move those into official operations? So we'd have bind, unbind, start.
Yeah, same as bind and unbind.
Yeah, same as bind, unbind.
Yeah, I think for Intel TDX, we don't have this specific requirement. Yeah, maybe for MD, there's some requirement because it also need to operate on the IOMMU.
Yeah, our ARM and Intel enable DMA step does not need to talk to the host. We just tell TDX module to unblock the IOMMU locally. But the
Yeah.
But
the start stop TDSP command need to transfer some shared blob to the host.
Right.
Yeah. That is not the not the same as evidence blob retrieval.
Right. Yeah. So these start stops would move out of guest requests. They would go into. They would become peers to bind unbind.
But there are also some other operations like read TDI state, something.
Yeah. What are all of them that we need? But that's not a blob, right?
That's not a blob. Is a for Intel it is a blob, but this is not evidence retrieval.
It's not evidence, but it's not. When I say blob, it's not something that can be multiple pages. This is a status code, right? Maybe 68 bytes, 16 bytes, something like this.
Yes. This is not a long blob, but it is still wrapped in a shared page regulated by GHCI.
This is the it's another tdisk command, right?
Yes, it will trigger another TDSP command.
Yeah, so we have get these version capabilities, interface requests. The device interface state command.
Yeah, yes. To report if it is locked or unlocked or runs.
Or runner error.
Yeah.
Okay.
Yeah.
But I mean, but yeah, but that's also one. Would we? I guess we would need to. We still need exit to QEMU because KVM doesn't have a mapping of. It doesn't know how to. It doesn't know the mapping of the exit payload
Yeah.
to device. Okay, that makes sense.
Yeah. Yeah, because the thing is that I'm not sure if it is actually necessary for host to distinguish the blob fetching and the state transition things, because at least for Intel, we as a host, the general host doesn't care about all these kinds of things, just to pass these blobs regulated by GHCI. Yeah. And I think I don't see many. I don't see we can save many code in the TSM, the host side TSM driver, because in this channel or another channel, we finally need these hardware operations to form these blobs. And
Right.
on QEMU side, I think there's some extra work, and it need to classify the evidence fetching blobs and the state transition and the state in transition operations, and use different interface to realize them. But I'm not sure that makes any sense, because anyway, QEMU is just a medium for passing these requirements from guest to host.
Yeah, it's not meant. Yeah, this proposal is not meant to save any code on the host side or on the QEMU side. It's
Yeah.
really its only reason for existing would be to have the possibility that we don't we would all share the same transport bugs in terms of between launch TVM launch attestation and PCI device attestation, like that. Everybody needs to get those megabytes because I recently merged a patch for expanding the size of the attestation report buffers because of of, of dice attestation. These things get bigger, and I think with post quantum computing, things keep getting bigger and bigger and bigger, and so um, and like and so on the launch attestation side, things like, oh well, the GHCI interface can't do scatter gather, so we have to allocate large contiguous guest blobs, and it's just like it's kind of a mess because like, oh well, ARM can do it, but Intel can't, or AMD can do this, and Intel, it's just like if it's everybody's using VirtIO or everybody's using the same channel, then it benefits from all the work that the VirtIO guys do to make that thing for performant and scatter gather supporting, and we just and then yeah, all the complexity can live on the host side, and the guests can all be the same.
But I'm thinking of a problem that the evidence collection process is vendor specific. Actually, some vendor maybe some vendor can retrieve one certification at one time, and sometimes and other vendors like Intel maybe cannot. It can just give a combination of the certification and measurement and all the other evidence in one web. So according to GHCI, then in order to honor the GHCI, do we still need to in QEMU side? Do we still need to read the evidence interfaces and recompose these evidence into to honor the GHCI and send to guest?
But I mean, are you asking about whether we need all the same evidence provided at the same time by all the same implementations? Because, like, I think if the let's walk, take an example of, we have a TDI, we want to validate it, and we say give me all the certificates you can see, give me the VCA, the measurements, the interface report, all the stuff. What the TSN driver can do is ask for all of those. It doesn't matter if some of them aren't provided, because for certificates on the guest side, we only have one. We can only return one certificate chain. We can't turn more than that, because the device is only allowed to attach to one at a time. So that problem solved. And then on some implementations, like on ARM, you might be able to get the VCA separately as a separate request. On Intel, that'll come back as empty. So the complexity of which architectures support which kind of parsing and subsets of evidence in different ways, that becomes the guest user space problem. And all the guest kernel has to do is just say, here's what I got from the host side. Hopefully something in here is useful to you. But I think Intel gives you, TDX gives you the entire transcript in the measurement blob, and so you would need to know that, if you want the VCA, it's actually in the transcript measurement blob, and you have to go pull it out of there and pull that signature.
So do you mean guest user space need to understand the GHCI or GHCB? Is it?
No. Guest user space needs to understand that. Guest user space would never know that there's any GHCI. It wouldn't. It would never know if you're using GHI, GHCB, or fetch blob. Guest would never know. Guest would just use netlink.
Okay.
And that's it.
Okay. So you mean that we use netlink, we do not need to use GHCI or GHCB definitions to fetch the blob, CC evidences.
Right. Well, it might still be those. Part of those we can't get away from. Like the fact that Intel gives you the entire transcript, and I think AMD does too, is different than ARM, which allows you to separates those things into different objects. But so user space would have to could see that difference over netlink. It would see, oh, hey, I can probably guess that my host is ARM based on the fact that I see this separate VCA version capabilities.
Netlink will just say one of two standard measurements blobs. One is just plain measurements, the other one is transcript.
Transcript.
It would be two different blob GUIDs, something like this.
So something like this, yeah.
Because see, a year ago, my PSP would give me just measurement blob, straight array of measurements. And now it's giving me transcript. So
okay.
At some point, we may maybe even be able to choose format. Someone asks.
Yeah. I think we're going to continue to see different architectures and implementations catch up with different schemes at different times.
Well, remember, what current IOMMUFD is missing is passing nonce from user space, from the guest, eventually, to make sure that measurements are fresh.
Yes, well, I mean, so that is in the netlink interface. You can pass a nonce when you so when you say dump the measurements, you can pass a nonce. Yeah.
Then something in TSM ops needs to accept this nonce and do something, like talk to TSM and get new measurements.
Correct.
We don't have this at the moment.
We don't this at the moment. Yeah. So the flow would be netlink in the guest, netlink dump the measurements with this new nonce. The TSM driver is notified and says, okay, it does a fetch Cocoa blob of say, hey, give me the measurements. Here's the nonce, and that goes over to QEMU, and it does the whole thing. Translates guest function ID to physical function ID, grabs the measurements, ships them back over, and then I think that, but then I think before returning to user space, before the netlink request starts populating, the TSM driver probably also wants to do another guest request to say, give me the digest of the blob I just got over this give me the digest of the thing I got over this thing, so that I can report the evidence blob with the secure digest with the nonce, all the whole thing out to the guest user space over netlink. So we'll see. So yeah, we can talk more about the IRC. I want to jump to a few other things because I didn't realize we spent 40 minutes on that. One thing that came up real quick, and I think Anish had brought this up. He was concerned about the case where you have uncoordinated guest, and it's like some admin 1, admin 2 for some reason are on this guest, and admin 1 is saying lock device, check evidence, accept it, and then another admin's on there doing, oh, I want to update the firmware, unlock, lock, and accept the device. And if those two things race, it could be the case that with sysfs, there's no kind of way to say, oh, make sure that the last I'm locking with the right measurements. So he was thinking about some kind of transactional interface to make sure that admin 1 sees that admin 2 messed up his lock. We can do that. It's hard to do with SSFS. That would be easy to do if we moved locking and accepting to netlink. And so then when you lock the device, you get a cookie or a session ID or a generation ID. And then when you accept, you have to play that same one back. And if things have changed and moved, you'll get an error message. I'm not convinced we need to do that because, like, I feel like guest user space should be coordinated. If you're trying to do lock and accept from 2 threads, you get to keep the pieces. But it is something. It is something simple. It is a simple safety measure we can do if we have a transactional interface. So, but Anisha's not here, so we can move on to this one. What I really wanted to get to was, do we understand how we're supposed to derive the obfuscated address? And so, Iluna, I saw your message. Did you give some more thinking about it, or do you want to share what you're thinking about this question?
No, I actually don't have. I think we only have. I can just think of two solutions. One is the same as ARM, that is to select a proper MML reporting offset, which will not blur the lower bits, then preserve the bar offset information.
The main question I'm asking Anish in this case, again and again, can we skip non-TE ranges in interface report? And if we can, then in what case? Because so far, the only documented case when you can actually skip non-TE region is MSIX, which is not locked. And we can know where is this MSIX region by looking at MSIX bar. If no other region can be skipped ever from the report, whether it's TE or non-TE, then that's easy to resolve. But Anish suggested that non-TE ranges can be skipped. And this part is not clear. And I asked my people, like my hardware engineers who read the spec or contributed to the spec, and they say everything must be reported except MSIX unlocked. Do you have the same understanding or not?
Well, I would say I'll put it this way. I would like to be that to be the understanding is that if Linux says put everything in there, we're going to assume everything's in there. And if you don't put everything in there and something breaks, we're not gonna have too much pity for you.
Then it must enforce the device vendors to conform to our restrictions.
Yeah.
Yeah.
Yes. Well, I mean, but we are writing we are writing a planet scale operating system, so we can have some opinions. I don't know, but this might be another one that we can also partner with Microsoft on. Deshuan, is what is, or maybe something you can find out is like is Hyper-V going to what is the Microsoft understanding of the interface report parsing, and can we get on the same page where we say KVM and Hyper-V are these VMMs expect devices to put all ranges in the interface, all MMIO ranges in the interface report. So I'll put it here.
Yeah. I think this is the first step that if we can have some consensus on the TSM side, Microsoft or Linux, but we also need to query the idea from DSM side, because the actual interface report is produced by device vendors. Yeah.
I mean, the interface report is produced by device vendors, but this is also kind of this is something that like there's things like WCL and other kind of OS kind of additional requirements that are kind of outside the specification, where you say, yeah, if you want, you can do whatever you want. Spec allows you to do whatever you want, but if you want like the certified for OS sticker, you're going to do it this
my
way.
hardware engineers say spec doesn't actually allow to skip. Spec says everything is in the report.
Okay.
Except MSIX and PBA?
Yes. There is this table about bits in the report about every range, and it says every range should be reported. Like in every reported range, it says it should be reported, but it's in the table when it describes the bit. So it's not like in the paragraph before the table. So you may think it's like there is a small context, which is about MSIX and not all the ranges. And, you can read it probably different. Well, read the same way, but you can, context is different. Context is smaller, and you may think that you actually allowed to skip non-TE bars, non-TE ranges.
I'd like to see all ranges being reported. That makes things easier.
Okay, we have the three votes for all range reported.
Yeah. I'm even wondering why the MSIX bars must be hidden. What's the intention from the TDSP also?
Well,
because it's outside of TDE, TCB. guest TCB. It cannot be part of guest TCB, so it doesn't need to be reported. Something like this, I heard.
But
Right.
it is the same situation as a non-T range, is it?
True.
Yeah. Yeah. But I think that's why people are thinking, oh, if the reason we don't report those is because, but let's say we get all ranges reported except MSIX, don't we still have the problem because we don't know, like if somebody puts the MSIX range at the beginning of a bar, you don't know it's there, and you would basically end up assuming that.
No, you don't know it's there because it's in MSIX bar as well. MSIX bar says where MSIX is.
Yeah.
Oh, okay.
Yeah,
You can find out it's there. You're right. Okay. All these other ones you can't find out they're there, then that's a problem. But this one we can at least fall back and say, yeah, not an interface report, but we can guess.
It's a problem if you want to use a MSIX relocate feature of QEMU, because you move MSIX and then you screw the whole report. But that's different thing.
MS relocation.
But we are not going to need this MSIX relocation when Yellow fixes DMA buff exporting from the FIO.
Oh, we can revoke and. Okay. Okay. So let's go with we kind of expect these things to be there. We'll at least that will be this. We'll put in the staging tree until somebody tells us that they're broken, and then we'll ask them why they're broken, and see. So we did get Jakob to look at the netlink interface. He thought it was kind of strange, but in the end, he's like, well, if these large blobs are not really what netlink handles well, but if you don't have any other options, here's some ways to make it more netlink friendly. So I'm gonna take a look at those. I think we can make progress on this because yeah, I don't think we have. I don't think we have anything better at this point, and other than a large pile of my octals, which is I don't want to do. I'm trying to save time for the SQL ID discussion. This Greg did come back and say he doesn't want to do CC accepted, which is fine. And I was trying to explain, like, well, CC accepted is different than authorized because I think Greg was looking for some unification, which I think is good. Linux should do this, and he wants a general concept of device trust, and I was trying to explain, like, oh well, CC accepted is a boolean and authorized is a boolean, and they don't really mean the same thing, and back and forth. And then Jason kind of observed that, like, if you look at those kind of two booleans together, CC accepted and authorized. Authorized is the old Thunderbolt thing to say, hey, is this device allowed to connect? It actually looks like an enum instead of a boolean. So if you turn trust into an enum, a value of different levels, then I think it starts to, I think that becomes easier to handle, or a concept that we can do, because we already have something in the kernel that does, like, privileges based on an enum, and that's the kernel lockdown feature.
Silly question. What's the difference between Thunderbolt authorized and TDs accepted?
The big difference is that authorized doesn't imply, like, when you change a device from authorized to not authorized, you don't have to go change your DMA settings.
Yes.
And
authorized is not reflected in hardware in any way?
Authorized, yeah. All authorized does is allow you to enumerate the bus, basically. So you plug in your Thunderbolt cable, it sees an entire. If it's not authorized, nothing happens. If it is authorized, then you see a whole bunch more PCI devices show up downstream. on that cable you plugged in. So it really is an enumeration gate, not really a. It's not something like CC accepted, which is like, oh, now you can talk to this whole brand new world of memory that you couldn't talk to before. So it's just more privileges. But yeah, but if we go with this enum and say, hey, like at trust level one, you can talk to shared memory, but maybe like we do privileges like, can you use ATS or not? Do I trust the device to use ATS or not? And then the highest level of trust is, do I trust this device to DMA to private memory? And that level of trust is only possible if you have a TSM attached and all these other kind of things. But as far as Linux is concerned, it's a continuum. So level 0, don't talk to it at all. Level 1, yeah, you can light it up, but maybe you can only do bounce buffering. Level 2, you can do full ATS, and level 3, you can do full confidential stuff, something like this. But so Greg, he didn't give a proposal. He just said not CC accepted, and please solve the multi-decade problem of device trust. Like, okay, this is a small ask, but I think
different level of trust.
different levels of trust. But I'm going to take Jason's suggestion and run with it and see
how can levels possibly work? You can have like TDs but no ATS, or vice versa, ATS but no TDs, and it's gonna be like level 3A and 3B, or it's gonna be Musk.
I think it's going to be not a mask, but levels, and that you have to go through the ATS trust level to get to the confidential computing level. So
so it's not like bigger number is higher class, and they are like orthogonal, or what? Which one is higher, TDs or ATS?
TDS is highest. TDS is highest.
Even without ATS.
Okay. Even without AT. Well, yeah. ATS.
And
ATS can rule the world.
Even higher, or what?
What was that last one?
TDs with ATS is even higher than TDs.
It would even be higher, yeah. But yeah, I mean, like if you look at the I don't know if you ever looked at the kernel lockdown levels, but there's like different things get turned off based on what level of lockdown you're at, and I think so. Like maybe root can't use devmem at all at the base level, but you can read PCI bars or something like this. Like there's different levels of privileges, and so we have to come up with some scheme that says that we can express how much we trust a device or not, and you have to get all the way to some high level before you can start talking to private memory.
Right. While thinking of this, remember we had discussion about having CBIT and DMA handles and how I do this with Vitom and all that stuff. And then I said I can actually have CBIT and DMA handles if I disable Vitom and keep DMA handles, CBIT and DMA handles. So now I have my test guest kernel with the kernel parameter which says use Vitom or don't use Vitom. And if I don't use Vitom, then I have another set of helpers like device CC accepted, but new set says device CC encrypted DMA thing, which then feeds to DMA helper calls to know if it needs CBIT or not. So it's like another level in this terminology, new terminology. It is like DMA is allowed is level 1, DMA is allowed with CBIT level 2 kind of thing. I really don't want to support both, but Vitom is like validated and tested heavily, and the other thing is not validated as heavily. So we probably don't want to support it right away. I'm still working with my hardware people about this.
Okay. I mean, it's so like we've had these kind of discussions too, and not about this specifically, but I'm talking about the general approach is we try to say like, hey, if it's simpler for Linux, Linux is going to implement to the hardware or to the kind of implementation that we want. We will do that first. And if you want Linux to support something more complicated, you can come back to us. But like our first approach is we're gonna write our implementation to the like same as on this thing. We're gonna write our implementation to the thing we want, and then challenge somebody else to come back and tell us you need to go further. And so that would just be my advice. Yeah, is to say like, hey, I'm gonna support BTOM disable. That's what's gonna go into mainline.
Yep.
And
That's
if
the
you guys
one.
want that, we can
I
come back
will
later.
talk my people more to pull from them if it's horrible idea or just bad idea, and if it's bad, then I'll implement the easiest.
Okay.
Bit and DMA handles. But when you think about levels of device trust, you include that as well.
Okay,
There may be in another level, which is like C-bit and DMA handles.
But does it actually involve a different level of trust, or is it really just it's more of a configuration thing? It's the same functionality. It's just a switch you need to say whether it's turned on or off, right?
It is configuration thing, yes. Maybe it's not another level, but it's like some bit which needs to be in somewhere in device structure or PCI TSM part of that.
I got it. Okay, yeah. So yeah, if we're carrying something along here, we need something that tells us how the DMA handle is constructed.
Right.
That makes sense. Okay, so in the last minute or so, what is your question about CXL IDE? So
so that there is the CXL spec which explains IDE, which is new set of keys for the same bus allegedly. It's wrapped into DOE. So I think TSM can handle it just fine. You do dev connect on CXL and it just does it. And then you pass it through and then you get this interface report, but it's not TDISP interface report, it's TSP interface report, which is like CXL protocol like TDISP, but not exactly. And does anyone talk about these devices in Intel?
We're talking about these. We're talking about accelerators in general, and accelerators with. I mean, because like the entire CXL development to date has been with only with memory expand.
I think what the question actually is can it be contained in TSM and leak no detail outside of TSM? Or something will leak like interface report. So is that it?
So for me, I've heard this kind of thing like, hey, can we handle CXL? Can we hide CXL inside PCIe? Like, I don't understand why we'd want to do that. I do understand that the CXL TSP specification was developed to be a memory expander first, and that was supposed to be a kind of a comprehensive trust model where basically your CXL is brought into the TCB just the same as your DDR at the beginning of time. And so as far as a guest would see, we would never see a device. You would never set up IDE for the OS because it would just be another memory controller that is trusted at the very beginning of time. But when we get to accelerators and devices that can be assigned, and those devices come with memory or not, then we need to figure out like, okay, like how do we dynamically figure out and set up that I think that breaks the TSP model.
But this new memory is still accessible via PCI link. It's not like PCI protocol, but it's still PCI hardware link, right? And it may same by.
It's still the same. Still the same electricals, but it's not an MMIO address. It's a host physical address. and on AMD sometimes it's even more obfuscated than that. But like it's not an MIO address, and so yeah, I would hope that CXL memory ranges are not reported in the MMIO, like in the PCIe MMIO ranges, because it's not an MIO range. But yes, yeah. I mean, for multiple people and across inside outside Intel, people ask this question about like, hey, what does it look like to have accelerator memory and get accelerator memory into the TCB? But yeah, so I'm willing to have those discussions here too. I think it's
but CXL spec describes IDE for CXL.
yes. CXL spec does describe CXL for ID, and but yeah, it also, well, the spec doesn't say it, but I think my understanding of of where TSP came from was that it was something like the OS would never need to set up CXL IDE, but I think now we're saying no, it probably is going to have to dynamically set up CXL IDE, and we have to start considering what that means to our implementation.
I mean, when you have the CXL, what entity does decide where CXL appears in system address space?
It's the same people.
Like,
Same people that decide where DDR appears in physical address space. It's the platform.
so platform decides.
Hardware map people, yeah.
So it's not like PCI bar, where host OS chooses.
It's not like it's a so there's a CXL fixed memory window structure that gets passed in ACPI, and that tells you, oh, these are your CXL ranges, and it'll also tell you these are the CXL ranges that can do device side accelerator memory, and these are the ones that can do general memory expansion. Like so, but yeah, that all comes through ACPI.
Is there such thing as CXL hot plug?
There is, but it is supposed to be managed. I mean, so, and that was one of the. I think that was other understanding of CXL TSPs. Like you can't hot plug these things when they come up. All the entire decode configuration is locked, and so that I think that works for general memory expanders, but it doesn't work for accelerators, especially if we're going to be resetting these things and knocking them offline and bringing them back online and that kind of thing. So, I think this is I think this discussion is something we need to have probably in this forum, because yeah, I think there's a lot of details to figure out that TSP kind of didn't need to consider with its memory expander focus. But I also want to make sure that like we're only talking about things that are public, and that anything that I mean, I think it's safe for us to read the spec, observe the spec, talk about what we see in the spec and where we'd like it to go, but we also can't talk about things that are happening inside the CXL consortium, because those discussions are confidential. What we've kind of been doing on the CXL side is making sure that we start all our discussions in public, and then we inform the consortium, hey, by the way, check out this discussion that's happening in the open, so that we don't get encumbered by confidentiality rules. But yeah, anything that you discuss that's not public in the consortium can't come into open calls like this. But we can go the other way around.
So far, all I know is from public spec.
Yeah, so. And everything I've said so far is also from public spec, so I think we're okay. But yeah, we can keep this discussion going on Discord, but I'm also interested in this space, and I think Anisha is too.
Good. Okay. So I'm looking at this interface report thing. So we just say everything must be reported, and wait till device vendors complain.
Works for me.
And then show the middle finger and say, go and change the report.
No, we can be more diplomatic than that, but effectively, yes.
Now, what my ex-colleagues do, they find this picture of Linus Torvalds and his gesture towards video and use that.
Alexi, Alistair found me at Plumbers, and he's been trying to get me to send you a picture of me giving you the middle finger, but I've so far refused. So
No, it's allowed. It's
it's allowed.
some Australian thing. Yes.
Okay. As long as I have your permission, then like next time I see Alistair, I said Alexi said I can, so I'm going to.
No, whatever Alistair suggests is good. Just do it.
Okay. Any other final questions, comments before we wrap up? Otherwise, thanks for the discussion, and we will see you all at the next one.
Thank you.
Yep, thanks everyone.
Thank
See ya.
you. Bye.
Cheers.
Thank you. Bye.